Before July 2015, every image of Pluto ever taken showed a blurry, reddish pixel. Scientists had spent decades studying that pixel, building models of what it might look like, and every single model was wrong. New Horizons did not just photograph Pluto, it exposed an entirely different class of world that nobody had predicted, and some of what it found still does not have a complete explanation. New Horizons launched on January 19, 2006, 9 years before it reached Pluto. It was the fastest spacecraft ever launched at the time, leaving Earth at approximately 58,000 kilometers per hour. Even at that speed, the journey took 9.5 years. It flew past Pluto on July 14, 2015, making its closest approach at about 12,500 kilometers from the surface, close enough to resolve features smaller than a city block. The encounter lasted only hours, but the data took over a year to fully transmit back to Earth, due to the extreme distance and low transmission rate. The first full image changed everything immediately. Scientists expected a heavily cratered, geologically dead world, a frozen leftover from the outer solar system with no recent activity. What New Horizons revealed was a world with young terrain, active geology, complex chemistry, and a history that extended far beyond the simple, frozen rock narrative. The heart-shaped feature, now called Tombaugh Regio, was the first thing most people noticed. The western half, Sputnik Planitia, is a nitrogen ice basin roughly 1,000 kilometers across, sitting in what appears to be an ancient impact basin. What makes it scientifically extraordinary is that it is not static. The nitrogen ice convects. It turns over in slow-moving cells driven by heat from Pluto's interior, similar in principle to convection in a lava lamp. The surface of Sputnik Planitia is geologically young, estimated at less than 10 million years, meaning it has been resurfaced recently in geological terms despite Pluto being 4.5 billion years old. The mountains were a complete surprise. Surrounding Sputnik Planitia are ranges of water ice mountains reaching up to 3,500 meters, comparable in height to the Rocky Mountains. At Pluto's surface temperature of approximately -233 degrees Celsius, water ice is rigid enough to behave like rock. These mountains are not made of frozen nitrogen. They are structural water ice that has not deformed under its own weight over billions of years. Their relatively young age suggests geological forces are still at work. The atmosphere defied expectations as well. Pluto has a thin nitrogen atmosphere that extends much higher than predicted. New Horizons detected it reaching up to 1,600 kilometers above the surface. The atmosphere shows distinct haze layers at multiple altitudes, similar in structure to the hazes seen on Titan. Complex organic chemistry is occurring in the upper atmosphere as ultraviolet light from the sun breaks down methane and nitrogen, producing compounds called tholins that give Pluto its reddish-brown coloration. One of the most scientifically significant findings involves the possibility of a subsurface ocean. Models of Pluto's interior, combined with New Horizons observations of surface deformation patterns and the size and shape of Sputnik Planitia, suggest that a liquid water ocean may exist beneath the ice shell. The basin of Sputnik Planitia appears to have reoriented Pluto, a process called true polar wander, where the mass of the basin caused the entire body to rotate, so the basin aligned with the tidal axis toward Charon. This kind of reorientation requires internal mobility that a completely frozen interior cannot provide. Charon itself delivered its own surprises. A vast canyon system called Argo Chasma stretches for approximately 1,600 kilometers and reaches depths of up to 9 kilometers, deeper than the Grand Canyon by a significant margin. Charon's North Pole is covered in a distinctive reddish cap composed of tholins, organic compounds that appear to have been captured from Pluto's escaping atmosphere and processed by ultraviolet radiation. Charon has its own complex surface history that models are still working to explain. New Horizons is now in the Kuiper Belt, having flown past the contact binary object Arrokoth in January 2019, the most distant object ever visited by a spacecraft. Pluto's data continues to be analyzed, and each reanalysis finds new details in the images and measurements. What New Horizons confirmed is that small, cold, distant worlds are not simple. They are geologically active, chemically complex, and full of processes that planetary science did not fully anticipate. Follow for more on the discoveries that rewrote the solar system's outer chapter. And tell me, if Pluto has active geology, a possible subsurface ocean, and complex atmospheric chemistry, what does that suggest about the other dwarf planets in the Kuiper Belt that no spacecraft has ever visited?